Welcome to 8.5, and it's a lesson essential question is, well, I guess we should add it questions. There's two of them. What are the complement angle relationships, and how do I use trigonometry to solve real-world problems? So let's start off with the first one, the complement angle relationships. So consider triangle ABC with right angle C. Angles A and B are complementary angles. So if x is, let's say, 50, and then I'd have 90 minus 50 is 40. Any number works. The trigonometric ratios also have complementary relationships. So let's fill out this table. So if I have reference angle A, sine, SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Good thing I know SOHCAHTOA. So if I have reference angles A, I'm going to say this opposite, hypotenuse, and adjacent. Now that I have all that and I know all this, I can make my ratios really fast. This is going to be A over C. Cosine is going to be B over C. Tangent is going to be A over B. And then now my reference angle changes. Now I'm here. This is no longer opposite, this is adjacent, and this is opposite, and hypotenuse stays the same. So sine is opposite over adjacent hypotenuse, so B over C. We have cosine of adjacent over hypotenuse, so A over C, and tangent of opposite over adjacent of B over A. So now summarize these relationships between trigonometric functions and the complementary angles. I notice something. This is the same, A over C, and this is B over C. And then these are reciprocals. So the cosine ratio is the same as the sine ratio on the other side. That's what this was all about. Moving on to the next part of the central question, if I'm going to do real-world stuff, I got to know how can I measure angles. So this guy's measuring the angle of this tree using an inclinometer. You're going to get to make one for the project. It's rudimentary. It's a straw with a protractor and a string and a weight. So I'm going to look through this, looking at whatever I have here. My partner is either going to look at this, or I could do it myself, and I could just grab it and remove it. So this angle would be starting at 0, going this way, would be about 42, 43 degrees. So once I have an accurate angle measure, now I can do stuff with problem solving. So first one, and the altitude of at an altitude of 100 feet, a balloonist measures the angle of depression of the balloon to the landing zone. The measure of that angle is 15 degrees. Now, the number one issue that kids are going to have is they want to say that, oh, thought that was going to work. Draw. This triangle, and this would be a right triangle as well, but they want to say that 15 degrees is this angle, and that is dead wrong. I don't have these things on many slides, I delete them, but the angle of depression is an angle below the horizon. So I start out at horizon and I measure down. So kids want to use this triangle. If you want to use this triangle, this line is a transversal and these are both parallel lines. So this is 15 as well. If I want to use this angle, I'd say, well, these are complementary. 15 minus 90 is going to give me 75 degrees. So I got to get my picture set up. So, and then the question says, how far is the balloon away from the landing zone? So that's this one. So I got all my tools in my toolbox. I got SOHCAHTOA. I'm going to stand here. This is hypotenuse. This is opposite. SOHCAHTOA. Which one deals with opposite on hypotenuse? You guessed it. Sine of 15 degrees would equal opposite 1,000 over hypotenuse, which is x. I'm going to do my switcheroo and do x equals 1,000 over the sine of 15. I can put this in my calculator, checking that my mode is in degrees. 1,000 divided by the sine of 15, and I'm going to get 3,863.7 feet. It's a unit. It's a real world problem, so I need a unit. The next one is this. To measure the Grand Canyon's width, the surveyor stands at a point on the north rim, so that's where he is standing, and measures the angle of depression to a point across at the south rim, so he's measuring here. And luckily the picture's drawn for us. I want to know the width across. So you pause the video and you try this problem. Welcome back. So if I'm here, this is opposite and this is adjacent. So I'm going to have tangent for opposite and adjacent of 19 equals opposite, which is 1,097 over unknown x. I'm going to switch these around. X equals 1,097 over the tangent of 19. Calculator tells me that is 3,185.9, and units are feet. So, hopefully you got that one right. Okay, we got another one. Bob dug a hole and is trying to measure how high up to the blue bob, that's this thing, I guess, on the top of the telephone. He knows the angle elevation is 30.55. Must have a computerized inclinometer because we're not going to get that accurate with ours. And he is 12.17 centimeters away. Bob's here. I have to identify. I want opposite then, and this would be adjacent. So you pause the video. What sine, cosine, or tangent function would I need? And then solve and turn the video back on. So hopefully you said tangent of 30.55 equals opposite, which is unknown, over adjacent, which is 12.17. So I'm going to multiply both sides by 12.17. So I have 12.17 times the tangent of 30.55. Put that in my calculator. Tangent of 30.5. And the height is going to be 7.18. Since they're using 2 decimal places, I'll use 2 decimal places. This would be feet. Now, you're probably wondering, why did he dig a hole? Well, if he didn't dig that hole, he would have to add this height from I down onto the bottom of the height that he got. He's only measuring from his eye. So we did a similar thing with our project in chapter 7 with similar triangles when you had the mirror and you looked down and then you looked up where I had to measure my height. So that's that. So for your project, you're going to do, well, I guess first, homework. You're going to need to do the Matthew and Delta math. Then when you finish that, you can start on the project. Project is you're going to go out into the commons area, and my room is just in this way. There's a line right here. It's right above the windows. There's a triangle roof piece. You're going to try to tell me how high this piece, this line is off the ground. And this going straight down meets at this post, so I can measure the horizontal distance of where I'm standing to this post, and then use my inclinometer, put the circle right here. Someone tells me the angle. I'm then going to basically be doing this question where this is the line. I can't dig a hole, so I have to add my eye height down, or whoever's eye height measured it was, and then you'll make a poster. So when you've got all this done, talk to me during the check-in.